All right. Hello, hello. We are taking a peek at the homework, kind of talking through that thing, and then we're just gonna be uh giving our or I'll be giving my farewell. Whoopsie. Don't need to open that. Yeah, that one. Hello, hello, and welcome. I was just gonna go over these questions. If you're looking at the beginning, I dumped them all into Desmos, so this was a no calculator problem, but nice to check your answer, sort of thing. Hello, hello, and welcome to the last stream of the year. There is no homework I'm assigning today unless you haven't finished your homework previous days, in which case you should do that and then email me so I can put it in the gradebook. I'm not going to accept any assignments put in the gradebook after Monday of next week at 1 p.m. because I need enough time to get that done before I go into school and get my room and all that. That's kind of my thinking. Hello, Michael and Rose and Groove and Harley. Yeah, again, if you are turning in late assignments, please have them in by Monday at 1 p.m. If you turn in anything afterwards, I'm not going to put it in the gradebook because I need to commit grades after that so I can get cleaned out of my room and done with it. Hey, Bren. Welcome, welcome. Hello, Elizabeth. If you don't know, there was an assignment on AP Classroom that is what I'm going over right now. I am not going to be grading that, like one by one and all that sort of thing, which is why I'm going over it right now. So if you just turn that in, I will be giving you credit for that. Yeah, that's what's up there. Hey, Liam. Hello, Ivan. All right. I figure might as well get started. We're starting to have more people show up, breaking double digits. Hey, Andrew. All right. So, the first one says find the area of R. If this is a no calculator question, this is the hardest one because the stuff's kind of a mess. So all of the area equation for R is the integral from 0 to 2. In the question, it says it's restricted by the y-axis and 2. Of top function minus bottom function, and the top function is the 6 minus 2 times x minus 1. Dude, and bottom function is the other one, the negative 2 plus 3 cosine pi over 2x. So yeah, this is kind of a mess to integrate by hand. If you integrate this by hand, you should get 44 thirds, or what I got in Desmos here, which I'm not mad if you used, which was 14 and 2/3, which is and that's just the integral from 0 to 2 of top function minus bottom function. The second one is actually one that throws a lot of folks for a loop because it's a little bit weird. The second one says region R is the base of a solid. For the solid at each x, the cross-section perpendicular to the x-axis has an area of 1 over x plus 3. All we do in cross sections is we integrate an area equation and we get a volume. So that's all we're going to do here is we're going to integrate from 0 to 2, because those are our x bounds, of the area equation. So none of the equations in the original problem matter here. All we do is integrate 1 over x plus 3 to natural log of x plus 3, and then plug in 0 and 2, and you get ln of 5 minus ln of 3, which is the right answer. And yes, Liam, 44 thirds is the right answer for A. This is the right answer for B, or if you use Desmos, you ended up getting this decimal, 0.511. Right there. Okay. And back to... For C, it says write but do not evaluate an integral expression that gives the volume of the solid generated when r is rotated around the line y equals 6. So I'm actually going to go up to the graph and put it on here instead of trying to do it down there. So y equals 6 is this line right here. And so if we reflect over, big R is down to the cosine graph, our g of x, and little r is actually to the other graph, our h of x. This distance is not the y value of the curve, it is 6 minus the y value of the curve, because 6 is where we start, and we just subtract whatever this coordinate is to figure out this distance. If we subtract a negative, we get a longer distance. If we subtract a positive, we get a shorter distance. 6 minus a positive is shorter than 6 minus a negative. So all we do is integrate from, and to break a record, 0 to 2, we throw a pi in front, and we do big R squared minus little r squared dx. Big R is 6 minus the cosine graph, which is g of x. And little r is 6 minus the other graph, the h of x graph. And so this is actually good enough to be done with C. That is the answer for C. Big R squared minus little r squared. This is a washer question. It's very important that you put the squareds around each of the individual parts. You couldn't say, 6 minus g of x minus 6 minus h of x or some garbage like this, and then square on the outside. That would be wrong. You need to put the squareds around each of the individual radiuses. So wait, when do we have the square inside of the integral? It's actually not just rotated things. So interestingly, related to that issue, when do we have the squared inside? Definitely when we rotate things, because we're integrating pi r squared. Or pi big R squared minus pi little r squared, which is this case. So this is washers, and this is disks, which is the same method. It's just one of them, the shape has a side that is attached to the line we're revolving around, which this almost does, but it just barely touches it. And here there's a cavity, a hole in the middle of this when we rotate around, which is why we had to use washers. Okay, the other spot where we have a squared inside our integral is when we do cross sections. Not this cross section in this question, because we actually got the area formula. But if we do cross sections of squares or triangles or semicircles, all of these equations have squareds in them. So squares have an area equation of side squared. Triangles, 1/2 base times height, which usually involves a squared because the base and height often are related to each other. And semicircles, 1/2 pi r squared, where r is what we're squaring. So squareds can show up inside our integral in almost all of our volume questions, because what we're integrating is the area, and there are often squareds in area equations. All right, hopefully that made sense and answered that question. Hello to our newly showing up people. Okay, so that is that's that question. Hopefully you did things at least somewhat right. I can say traditionally on AP Test, B throws people for a loop because they introduce a new area equation and a lot of people panic, when in reality it's actually way easier if they give you an area equation, because all cross sections are, is integrate area. So if they give you area, you just plug the area equation, the integral. Are we learning any new things today? No. No, we are not. In fact, we're kind of done with the content. Anything you learn... Oh, sorry for hitting the microphone there. Anything you learn further than this is just going to be, like, in Brusich's class next year. Which, decent chance that's going to be online. We just did a big Canvas training, which is like a better Microsoft Teams. And we're going to be putting all of our websites on that, so Connect is dying. All that kind of stuff. Oh yeah, by the way, if you have a calculator, you can actually do question C, part C. And the volume of that thing revolved around actually has a big, like it's big volume. 425.372. Wowzer. Okay. Last part of this not super duper long stream is, I think it's this one. Am I dumb? Goofing. Huh. Thank goodness I hate Connect. Yes. Many of us hate Connect. Uh-oh. My settings are all messed up. Sorry. See if I can fix this. Oh, I'm just actually really dumb. I think. No? Well, I sound spooky. Yeah, it's because I had the audio on my computer also picking up with my microphone, which is very confusing. Okay, I was gonna do like a face cam thing, but now I can't figure that out because I'm actually really dumb or something. Very confused. I don't like that audio. Yeah, so, apparently I didn't get this figured out. I swear I had it figured out. I must have, like, some sort of driver issue, which is really wonderful. Very, very, very wonderful. And I can totally be very confused about this. Okay, so really all I wanted to do here was say thank you for trying hard this year and learning stuff and making yourself smarter. I am sorry things went so poorly. I've actually had an extremely rough and busy year on top of just this school thing, so I'm sorry if I've been a little distant and that sort of thing. You didn't get the best version of Mr. Kennedy this year. I was not as engaged as normal. And I apologize for that. I apologize for not following through on some stuff and being generally a little less awesome than normal. So, yeah, thank you for being patient with me this year, and I really appreciate all of you, and I really hope you guys see success in the future and all of that, because you guys are a pretty awesome group, and I really appreciate it. And I'm sorry, I really can't figure this out. This was working. If I restart my computer, it'll probably work perfectly, but I'm not going to do that. And I apologize for the lie on the face reveal. Because, yeah, apparently that's not even working. They have this thing where I never show my face during Zoom meetings, and so I haven't put a lot of effort into this. Because I don't want to show them that I'm playing video games while doing a staff meeting. So yes, thank you, and I hope you enjoy everything with Kruzich next year, because that should be a blast. And Cody, I have not checked your assignments yet, but I'm gonna put them in right after this. So yeah, just quick feedback on that. All right, sorry. Oh, Probably have the face cam thing fixed for Algebra 1 tomorrow. But you guys don't get it. So yeah. Later, dudes. Please turn in any missing assignments by Monday. Monday of next week at 1 p.m. is the deadline for missing assignments. And otherwise, have a wonderful summer. Adios, amigos. Yes, Elizabeth, I will check late work on AP Classroom. However, you should tell me you did it so I can check you, because it doesn't like tell me a list of assignments that have been submitted. I can only click on an assignment and see who submitted it. So it's very hard for me to actually cross-reference that skyward without an email. So please email me if you turn in any late assignments. When is the grade adjustment going through? It's going to be after. It's going to be after Monday, after 1 p.m. on Monday. That's part of the reason I need things in. Grades aren't technically due till the next day, but I have to go through and grade adjust like 100 of my students. It's gonna take a couple hours, and so I just need a chance to do that. So that's part of the reason I'm asking people to turn things in a little bit early. So yeah, please email me if you are turning in anything. And yeah. Okay, now I will go. It's like I answered the questions. Feels good. Alrighty, bye-bye.